Good evening, student. So today in this lecture, we are going to start the first chapter of class 12 chemistry, that is solution. So before going into the chapter, so let us know what are the topics that will be covered in this particular chapter. Okay. So in the first part there will be introduction to solution. Okay. Followed by that there will be classification of solution. That means we will be classifying the solution on the basis of physical state as well as on the basis of number of components. Followed by that we will be discussing about concentration of the solution. In this particular part we will be discussing about molarity, molality, mass percentage, volume percentage, etc. And followed by that we will be discussing about solubility of the liquid solution and what are the factors that will be affecting the solubility. So that part we will be discussing. Followed by that we will be discussing about the vapor pressure of the liquid solution, and then we will be discussing about ideal and non-ideal solution, and also we will be discussing about different type of non-ideal solution and its characteristic, and followed by that we will be discussing about the azeotropic mixture as well in this particular part. And after that we will be discussing about the colligative properties. In this part we will be discussing about what are the different colligative properties, what are its application, and also the limitation as well. And finally we will be discussing about abnormal molecular mass and Van 't Hoff factor. Okay, is that clear to everyone? So these are the topics that will be covered. Okay, so now let's move to the first part. Okay, that is introduction to solution. So you know, my dear student, you had already studied about matter in class 11, right? So whatever we see in our surrounding, so these are called as matter, right? So basically how do we define matter? Matter is anything that occupies space and has mass, right? Okay, so this matter can be classified into two types on the basis of the composition. Okay, fine. On the basis of composition we can classify matter into two types. The first one is pure substance or substances. The other one is mixture. Okay, so now what you know what is pure substance, right? So it is made up of only one kind of elements, or it is made up of only one type of compounds or molecule. So you had already studied about this example, right? Example of pure substance, H2, CO2. So this is a molecule, so this is a compound, right? So in that way NaCl, right? So these are example of pure substance. Okay, you also know about mixture, right? Fine. So mixture, it is a combination of two or more pure substances. Okay, so you can take up many examples as such. So mixture of salt and sand, mixture of salt and water, mixture of sand and sugar. So in that way you can take up many examples for the mixture. Okay, so this mixture, on the basis of the mixing, how it has been mixed, it can be further classified into two types. Okay, so one is homogeneous mixture, the other one is heterogeneous mixture. Okay, so in this way we can classify the mixtures into two types. One is homogeneous mixture and the other one is heterogeneous mixture. Okay, so in case of homogeneous mixture, the pure substance will be uniformly mixed. Okay, so here there will be uniform mixing. Okay, fine. So it will be mixed uniformly. So you can take up many example of homogeneous mixture. Example, the sugar solution. Okay, sugar in water, salt in water, so these are NaCl in water. So these are example of homogeneous mixture. Okay, is that fine? So in a similar way, in case of heterogeneous mixture, you can take up, so heterogeneous mixture, in case of heterogeneous mixture, it will be mixed non-uniformly. So you can take up many examples as such where there will be non-uniform mixing. Okay, so here mixture of sugar, that is sucrose, sugar plus NaCl. If you mix these two components, they won't be uniformly mixing. So this is an example of heterogeneous mixture. Okay, so similarly as I have told you, in case of homogeneous mixture, NaCl in water, NaCl in water. Okay, so this is an example of homogeneous mixture. So homogeneous mixture, so this is also called as homogeneous mixture. This is also commonly called as solution. Is that clear? Homogeneous mixture of two or more substances, so that is also commonly called as solution. Fine. Okay, so now we know what is solution. What is a solution? Solution is a homogeneous mixture of two or more substances. Okay, what is a solution now? solution. So how can we define solution? So we can define solution in this way. It is a homogeneous mixture of two or more pure substances. Fine. So we use homogeneous mixture or solution in many ways in our day-to-day life. Okay, example, so take the case of lemon juice that we used to consume during the summer. So it is an example of homogeneous mixture. Similarly, tea that we used to drink, so that is also a homogeneous mixture. Fine. Okay, so now let us go for the classification of solutions on the basis of number of components and also on the basis of physical state. Okay, now you know what is solution, right? So let us go to the classification part now. So we will be classifying the solution first on the basis of number of components. So now let's classify the solution on the basis of number of components. So as you know, solution is a homogeneous mixture of two or more components, right? So that means there should be minimum two pure substances. It cannot be lesser than that. So that means, so minimum number of component will be the case where there will be two pure substances, and that particular solution where there is two pure substances are there, so that is called as binary solution. Okay, so similarly, if there are three pure substances, if three pure substances are there, then that will be called as ternary solution. So if there are four pure substances are there, then it will be called as quaternary solution. So we can classify the solution on the basis of number of components in this way. So we can keep on classifying. Okay, but our main focus is on binary solution. Is that clear? Okay, so now let us define what is binary solution. So we can define in this way. It is a homogeneous mixture of two pure substances. Fine. So in this way we can define binary solution. So example of binary solution we can take in this way. Okay, NaCl dissolved in water. NaCl is one of the pure substance and water is the other pure substance. Okay, fine. So here NaCl will be the solute and water will be the solvent. Okay, remember here, so while representing, so we used to write the solute first followed by the solvent. Is that clear? Okay, so that is the basic pattern that we used to follow, or the standard that we used to follow while writing binary solution. Okay, so similarly you can take glucose in water, glucose C6H12O6, glucose in water. Okay, so here similarly glucose will be the solute and water will be the solvent. So these are two of the examples. Okay, similarly let us now discuss about the ternary solution. So what is a ternary solution? It is a homogeneous mixture of three pure substances. So it is a homogeneous mixture of three pure substances. We can take the example in this way. You know that NaCl and glucose, both of them they used to dissolve simultaneously in water. NaCl plus glucose plus water. Okay, so here in this particular type of solution, so there will be two solute, one is NaCl and the other one is glucose, and the solvent will be water here. Okay, so that means in a solution there can be more than one solute. Okay, but the solvent will be only one. Fine. So here NaCl and glucose is the solute and water is the solvent. Fine. Okay, so similarly you can take other example as well. NaCl plus KCl plus H2O. You know that NaCl and KCl both of them are salt and they will be dissolving in water. So here NaCl and KCl both of them are solute and water is the solvent here. Is that clear? So in this way we can take many more examples for the ternary solution. Okay, fine. Okay, so similarly let me define what is quaternary solution. It is a homogeneous mixture of four pure substances. So quaternary solution, it is a homogeneous mixture of four pure substances. Okay, so you can take example of this. You can take the name of three of the salt and you can dissolve it in water. So that will be one of the example of quaternary solution, like NaCl plus KCl plus RbCl plus H2O. Okay, so here NaCl, KCl and RbCl. Okay, these are the three solute and water will be the solvent here. Is that clear? Okay, so similarly you can take glucose plus NaCl plus KCl plus water. Okay, so here also you can see 4 components: glucose, NaCl, KCl and water. Okay, so here this glucose, NaCl, KCl, so they will be solute in this solution and water will be the solvent. Okay, is that clear to everyone? So we will be classifying the solution on the basis of number of components in this way. Okay, so we need not go beyond quaternary solution. You might be thinking about that the number of components can be more than 4 as well, right? Yeah, whatever you are thinking is correct, but we are not concerned about those type of solution. Okay, so let me explain in detail about the binary solution. Is that clear? Okay, binary solution, basically it will be consisting of 2 pure substances. Okay, and of these 2 pure substances, one will be called as solute and the other one will be called as solvent. Okay, one of them will be called as solute and the other one will be called as solvent. Okay, now the question is, what is solute and which one will be called as solute and which one will be called as solvent of the 2 component that is present in the binary solution? Okay, in case of solute, okay, the component which will be present in lesser amount, okay, that will be called as solute. Which one will be called as solute? The component of the binary solution which will be present in lesser amount will be called as solute. Okay, present in lesser amount. Obviously, since it is a binary solution, so there will be only 2 components. Okay, so in case of solvent, it will be present in higher amount. Okay, it is that component of the binary solution which will be present in higher amount. Okay, fine. So example, if you want to take example, so take the let us discuss about the previous case where we had dissolved NaCl in water. So in that case, NaCl dissolve in water. So here, as you know, this is a binary solution. NaCl is one of the pure substance here, and the other pure substance is water. So NaCl will be called as solute here. NaCl will be called as solute. NaCl will be solute in this particular solution. Okay, fine. And the water that is present in this binary solution will be called as the solvent. Okay, fine. Example, the solvent when NaCl is dissolved in water. So when NaCl will be dissolved in water, so water will be the solvent. Water will be our solvent. Fine. So you can take up many examples as such. So this is one of the examples. So you can take the example of glucose dissolved in water. So similarly, benzene, mixture of benzene and toluene. So that is also a homogeneous mixture. So you can take example in that way. Okay, there are many examples of binary solution. Fine. I had given one of the example here. Okay, fine. So now, so let us discuss about the classification of solution on the basis of nature of the solute. Is that clear? On the basis of nature of the solute. Okay, so now let's discuss about the classification of the solute. So you know what is solute, right? The component of the binary solution which is present in the lesser amount. Fine. Now, this solute can be classified into 2 types. One is electrolytic solute. The other one is non-electrolytic solute. The question is, what is electrolytic solute? Fine. What is electrolytic solute? So this type of solute, when you dissolve in solvent like water, okay, in the polar solvent like water, so it will be dissociating to produce ion. Okay, so electrolytic solute dissolve in solvent to produce ion or ions. Okay, so you know, when example, let me take example, when NaCl is dissolved in water, it dissociates to give Na plus and Cl minus ion in water, right? NaCl, when it is dissolved in water, okay, so it will be giving Na plus and Cl minus. So this type of solute, which when dissolved in water or any polar solvent dissociates to give ions, are called as electrolytic solute. Okay, so you can take up many examples as such. Okay, all the ionic compound, when they will be dissolved in polar solvent like water, so they will be dissociating to produce ion, and all these solutes will be called as electrolytic solute. K2SO4, So remember, all the acid as well as base, so they are also electrolytic solute. Okay, now the next one, non-electrolytic solute. Okay, so this type of solute, when they will be dissolved in water, so they won't be producing ion. They will dissolve, but they won't produce ion. So you can take up example as glucose, sucrose. So this will dissolve in glucose and sucrose. It used to dissolve in water, but like NaCl, it won't be producing ions. Okay, NaCl, just like NaCl, it used to produce Na plus and Cl minus ion. So glucose, it won't be producing ion in that way. It will be dissolving, but it won't be producing ion. Fine. Okay, so we can take up example glucose C6H12O6, sucrose C12H22O11, right? So urea. Okay, solvent. In the similar way, just like solute, solvent can also be classified into two types. One is polar solvent and the other one is non-polar solvent. You know about polar molecule. So polar molecule will form polar solvent and non-polar molecule will form non-polar type solvent. Okay, and what are the substances that will be dissolved in polar solvent? The substances which are polar in nature, and along with that all the ionic compounds, so they will be dissolving in the polar solvent. Okay, solvent will be polar in nature, and here all ionic compound and polar solute will dissolve. Fine. So if you want to take the example of polar solute, glucose, sucrose, urea. So these are some example of non-electrolytic solute which we had already discussed. So these solutes are polar in nature, and similarly KCl, NaCl, Na2SO4, etc. So these are ionic compounds, right? So these are ionic compounds. All these solute, so they will be dissolving in polar solvent. Okay, that means the polar solute as well as ionic compounds, so they will be dissolving in the polar solvent. Similarly, in case of non-polar solvent, so non-polar solute will dissolve in non-polar solvent. Non-polar solute. Example, so you can take up, like if we take the example of toluene dissolve in benzene. So toluene and benzene, both of them are non-polar. So if we take benzene as the solvent, so toluene will be the solute, and this toluene, so it is non-polar in nature. Okay, so similarly heptane dissolve in octane. So these are example of, so here heptane will be non-polar solute and so is octane solvent. Okay, so these non-polar solute, so they will be dissolving in non-polar solvent. Fine. So in this way we can classify the solvent into polar and non-polar type. So now let us classify the solution on the basis of physical state. Okay, as I had already told you when I was discussing the types of solution on the basis of number of components. So our main focus will be there mainly on the binary solution. Okay, binary solution where one of the component will be solute and the other component will be solvent. Okay, now so you know that this solute can be there in 3 physical state. How many physical state? 3 physical state. Okay, so similarly the solvent can also be there in 3 different physical state, that is solid, liquid and gas. Okay, so solute can be there in 3 physical state, that is solid, liquid and gas. So is the solvent. Okay, so based on this, okay, so based on the physical state of solute and solvent, we will be getting 9 different types of solution. How 9 different types of solution? So what are the possible state? So let's say solute is in solid state, or similarly it can be in liquid state as well, or in it can be they are in gas state as well. Okay, and so is the solvent. So solvent can also be there in 3 different state, that is solid, liquid and gas. So these are the 3 possible states of solute and solvent. Okay, fine. So now the solute can be in solid state and so is solvent. So if both of them are in solid state, then we will be getting one type of solution. Similarly the solute can be in solid state and the solvent can be in the liquid state. So in this way we will be getting second type of solution on the basis of physical state. The next one, the solute can be there in the solid state and the solvent can be there in the gas state. So in this way we will be getting three types of solution when the solute is in solid state and the solvent is in solid, liquid or gas state. Similarly, when the solute is in liquid state, the solvent can be in solid state. Similarly, the solvent can also be in liquid state and solvent can also be in gas state. So in this way we will be getting the next three type of solution on the basis of physical state. So similarly, when the solute is in gas state, the solvent can be in solid state. Okay. So similarly, the solvent can be in liquid state and the solvent can be in gas state. So in this way, so we will be getting the next three type of solution. So that means on the basis of physical state we will be getting total 9 different type of solution. Fine. Okay, so let us now learn these 9 different types of solution one by one with an example. Okay, so I will be keeping the phase of the solvent same. So now let us classify. Okay, the solute can be in solid state and the solvent can be in the solid state. Similarly, the solute will be in liquid state. If the solute is in liquid state, the solvent will be in solid state. If the solute is in gas state, the solvent will be in solid state. Okay, so these are the 3 combinations that are possible for solute and solvent on the basis of physical state if the state of the solvent is solid. So similarly, if the solvent is in liquid state, so similarly you will be getting 3 combination in this way, where the solute is in solid state, solvent is in liquid state, and similarly the solute is in gas state and solvent is in liquid state. So in this way we will be getting next 3 types of solutions. Similarly, if I keep the state of solvent as gas, so we will be getting the next 3 type of solution. When the solvent is in gas, the solute can be in solid state, or it can be in liquid state, or it can be in gas state. So in this way total we will be getting 9 different type of solution on the basis of physical state. Now, so what will be the physical state of the solution on mixing? Okay, so let me take an example. Okay, so when we dissolve sugar in water, okay, so sugar is in solid state and the solvent it is there in liquid state. Now what will be the phase of the mixer, okay, or what will be the phase of the solution? Actually, so you should be knowing this term, okay, or this particular concept, that when the solute will be dissolved in solvent, the phase of the solution will be same as that of the solvent. Okay, the phase of the solution will be same as that of the solvent. So that means if the solvent is in solid state, then the solution will also be in solid state. Similarly, if the solvent is in liquid state, the solution will also be in liquid state. If the solvent is in gas state, the solution will also be in gas state. Is that clear to everyone? Okay, fine. So here the state of the solution will be solid and here also it will be solid. So this will be solid. Okay. So here, since the state of the solvent is liquid, so here the phase of the solution will also be liquid. So here also it will be liquid since the solvent is in liquid state. Okay. So here the solvent is in gas state and the solute are in 3 different states. So here in all these cases the solution will be in the gas state. The solution will be in the gas state. Fine. So similarly here, what will be the name of this particular solute? Okay. So if the solution is there in the solid state, then the name of the solution will be solid solution. So that type of solution will be called as solid solution. Okay. So these three solution. Okay. So these are called as solid solution. So similarly, the next 3, these 3. So since the solvent is in liquid state and so is the solution, so this type of solution, so that will be called as liquid solution. Okay. So the next 3 type. Okay. So here the phase of the solution is in gas. So that is why. So these 3 solutions are called as gaseous solution. So out of these 9 different type of solution, we won't be focusing on each and every type of solution. Going forward, we will be only discussing mainly on liquid solution. Okay. We won't be discussing about solid in solid, solid in liquid, or in that way. So all the 9 different type of solution we won't be discussing about going forward. Out of this only we will be taking out liquid solution and we will be discussing about that in detail going forward. Okay, fine. Now, So let us discuss the example of solid in solid type solution. Okay, so that means solute will be in solid state and so is the solvent. Okay, so can you give me an example? Okay, so alloys, right? Alloy of copper and zinc, alloy of Cu and Zn, right? So similarly you can take alloys of copper and gold. Okay, so you can take up many examples as such where both the solute as well as solvent will be in the solid state. Okay, the next one is liquid in solid type solution. So for this, so now for the next type of solution, that is liquid in solid type solution. So example will be mercury dissolved in sodium metal, Hg in sodium, Na metal. Okay, so you know that mercury, it used to be there in liquid state. Okay, you know that mercury is the only metal that exists in liquid state at room temperature. So mercury dissolved in sodium, so sodium will be in solid state. Next, gas in solid type. Okay, so you have already studied about this in hydrogenation of vegetable oil. Okay, so in that hydrogen gas used to dissolve on palladium surface, okay, or throughout the bulk of PD. So this is an example of gas in solid type solution. Okay, for the next type of solution, that is solid in liquid. So for this, you know, there are many examples, right? Sucrose dissolved in water, sucrose is in solid state, and water here, which is the solvent, so that is in liquid state, sucrose in water. Okay, next, liquid in liquid. So this is the very common example is mixture of ethanol and water, ethanol and water, liquid in liquid. So ethanol, you know, that is being used to consume, right? So this is an example of liquid in liquid type solution. And next, gas in liquid type solution. So for this, you know, so oxygen gas, right? So it is used to dissolve in water, and you know that marine water, a marine living creature, so they used to exist because of this dissolved oxygen gas. Okay, so the living organism that are found in water bodies, it is because of the dissolved oxygen gas. So that means gas used to dissolve in water. Okay, so O2 gas dissolve in O2 in water, right? O2 in water. So that is an example of gas in liquid type solution. Now, okay, for the next type of solution, that means when the solid is in when the solute is in solid state and the solvent is in gas state. So this solution, it is also called as solid in gas type solution. Okay, so for this, common example is naphthalene, naphthalene ball. Okay, you know, naphthalene in N2 gas. Okay, naphthalene in N2 gas. So this is an example. Naphthalene will be in solid state and N2 will be in gas state. So similarly, liquid in gas type solution. Okay, so for this example will be, so for liquid in gas type, so chloroform, you know that chloroform. Okay, what is the use of chloroform? Chloroform in N2 gas. Very good. Okay, the next one is gas in gas type. So for this, you know that mixture of oxygen and nitrogen gas, mixture of O2 and N2 gas. So this is an example of gas in gas type solution. So in this way, so we can classify the solution into 9 different types on the basis of physical step. Okay, fine. So here, going forward, we won't be discussing about this solid in solid. Okay, nor we will be discussing about going forward about liquid in solid, nor in gas in solid. Okay, so we will be discussing about this going forward. So this type of solution we will be discussing about, this we will be discussing about. Okay, so we won't be discussing about this type of, okay, fine. So this also we will be discussing. So that means out of the 9 different type of solution, so our main focus will be on only 4 different type of solution, only these 4 different type of solution that I had marked here. Is that clear? Okay, fine. So I think it is clear to everyone. Fine. Okay, so with this I am ending today's lecture. So in the next lecture we will be discussing about the concentration of the solution. Okay, as I had already told you, so going forward we will be discussing mainly about the binary solution. We won't be discussing about the other type of solution. And on the basis of physical state, as I have told you, so we will be discussing about the liquid solution and gaseous solution. Okay, so we won't be discussing about the solid solution. Is that clear to everyone? Okay, thank you, and we'll see you on the other day.